Every naval history video shows the battles, the explosions, the sinkings. Nobody shows what happened next. A destroyer limps into Alexandria harbour with a shattered bow and flooded compartments. A cruiser trails oil from ruptured fuel tanks after a near miss from a 500-pound bomb. A carrier's flight deck is buckled, her aircraft grounded, her striking power reduced to zero. What happens to these ships? In 1942, a single British repair ship, HMS Resource, was anchored at Alexandria, patching battle damage on destroyers, cruisers, and carriers faster than the Luftwaffe and Regia Marina could inflict it. She carried a foundry capable of casting 1,000 pounds of iron, a smithery with pneumatic hammers and forging presses, machine shops with heavy lathes, gear cutters, and milling machines, an optical instrument workshop, electric welding equipment, coppersmith facilities for pipe work up to 4 inches, all of this aboard a single vessel displacing 12,300 tons. No dry dock, no shipyard, open anchorage repair performed while the Mediterranean fleet fought for survival. Resource was the only purpose-built fleet repair ship in the entire Royal Navy when war broke out. One ship. The Germans had nothing equivalent. To understand why Britain built HMS Resource, you need to understand what no other navy in 1928 fully grasped. Britain did not operate a home waters fleet. The Royal Navy maintained squadrons across the globe, from the Mediterranean to the China Station, from the South Atlantic to the Indian Ocean. When a destroyer's turbines failed in Malta, the nearest British dockyard capable of major overhaul was Gibraltar, over 1,000 nautical miles west. When a cruiser took shell damage off Alexandria, the closest home dockyard was Portsmouth, over 3,000 miles away through waters that might be hostile. Every warship that sailed back to Britain for repair was a warship removed from the fighting fleet for months. Transit time alone could consume weeks. Then add dockyard queues, then add the repair itself, then add working up and transit back to station. A destroyer with moderate battle damage might be absent from the Mediterranean fleet for 4 to 6 months. Multiply that across dozens of vessels, and the effective strength of any overseas fleet shrank dramatically. The Admiralty recognized this vulnerability after the Great War. Ships damaged at Gallipoli and in the Mediterranean had to be sent to Malta or even home for repairs that a well-equipped floating workshop could have completed in days. In 1927, the Admiralty placed an order with Vickers-Armstrongs at Barrow in Furness for something no navy had ever purpose-built on this scale, a dedicated fleet repair ship designed from the keel up to serve as a floating dockyard. She was launched on November 27, 1928, and commissioned in 1929 as HMS Resource. Her specifications reflected the Admiralty's ambition: 530 feet in overall length, 83 feet in beam, a draft of 22 feet 4 inches at full load, 12,300 tons displacement. Her propulsion consisted of steam turbines driving 2 shafts, producing 7,500 shaft horsepower for a maximum speed of 15 knots. She was not built for speed, she was built for capability. Her armament was 4 4-inch low-angle gun mountings, enough for self-defense, not enough to fight. Her purpose lay below decks. Resource carried a comprehensive suite of workshops that replicated the essential capabilities of a shore dockyard. A pattern shop and foundry, capable of producing brass and iron castings up to 1,000 pounds. A coppersmith's and plumber's shop, equipped for all pipe work up to 4-inch diameter. A smithery and plate shop, fitted with pneumatic hammers, a forging press, bending slab, anvils, quench tanks, plate shearing machines, bending rolls, and oxyacetylene cutting and burning equipment. An electric welding shop with capacity for 10 welders working simultaneously. A heavy machine shop containing borers, planers, heavy lathes, gear cutters, and milling machines. A light machine and engineers fitting shop with radial drills, light lathes, universal millers, slotting machines, and grinding equipment. A torpedo repair shop. A carpenter's and woodworking shop. An optical and instrument workshop containing watchmakers' lathes and precision benches for repairing rangefinders, gun sights, and navigational instruments. An ordnance workshop, an electrical test shop, a drawing office for planning repairs. Each workshop was equipped with overhead travelling cranes capable of lifts up to 4 tons. Her peacetime complement was 581 which included specialist repair staff drawn from Royal Navy dockyards. These were not ordinary sailors. They were artificers and skilled tradesmen, men who had served apprenticeships in Chatham, Portsmouth, Devonport, and Rosyth before going to sea. Coppersmiths who could fabricate replacement piping systems from raw materials, foundrymen who could cast replacement fittings that no supply chain could deliver to a forward anchorage, electricians who could rewire damaged circuits in compartments still stinking of cordite and fuel oil, shipwrights who could cut away buckled hull plating and weld replacement sections while the ship sat at anchor. During wartime, her complement increased substantially to maintain continuous repair operations. When war broke out in September 1939, HMS Resource was deployed at Malta, providing support for the Mediterranean fleet. She was the sole purpose-built fleet repair ship in the entire Royal Navy. Every other navy in the world either relied on shore dockyards or improvised with depot ships that carried limited repair capability. The Admiralty had anticipated this shortage. They simply had not built more ships in time. Resource's Mediterranean service from 1939 to 1944 represented the most intensive period of fleet repair operations in Royal Navy history. She spent the opening months of the war at Malta, then briefly transferred to Freetown in early 1940 before returning to the Mediterranean once HMS Edinburgh Castle arrived as a permanent facility in West Africa. From 1941, she was based primarily at Alexandria, operating alongside the Mediterranean fleet during its most desperate years. This was the period when the fleet fought to keep Malta alive, escorted convoys through Bomb Alley between Crete and North Africa, and engaged Italian surface forces in a series of brutal night actions. The fleet was under constant air attack from the Luftwaffe and Regia Aeronautica. Destroyers returned from convoy escort duty with splinter damage, ruptured fuel tanks, damaged propulsion systems, and shattered electrical circuits. In April 1941, the Australian destroyer HMAS Vendetta arrived at Alexandria with condenser trouble and was taken directly in hand for repair by Resource. This was typical. Ships arrived damaged, Resource fixed them. They returned to the fight. Cruisers limped in after surface actions with structural damage that would have required weeks in a home dockyard. Resource's artificers took them alongside and worked around the clock. The difference between Resource and a shore dockyard was speed. A destroyer with moderate battle damage, hull plating holed above the waterline, a damaged turbine, and electrical failures in her fire control system might require 3 to 4 months for repair in a home dockyard, including transit time. Resource could complete the same work in days to weeks, depending on severity, because the ship was already at the fleet's forward base. No transit, no dockyard queue. The warship went alongside Resource, repair crews swarmed aboard with welding equipment and spare parts, and the ship returned to the fighting fleet as soon as work was complete. In the Mediterranean, where every destroyer and cruiser mattered, this capability was the difference between a fleet that could fight and a fleet that could not. If you are finding this deep dive into Royal Navy engineering valuable, consider subscribing. It supports the channel and ensures you do not miss the next one. The true scale of Britain's challenge became apparent as the war expanded. Resource was one ship. The Mediterranean fleet alone was losing and damaging vessels faster than one repair ship could handle. In 1940, the Admiralty recognized that additional afloat repair capacity was an urgent requirement. They selected the Cunard liner Antonia for conversion, completing her as HMS Wayland in 1942. Wayland's conversion provided 37,000 square feet of workshop space, 3 additional 300-kilowatt turbo generators, and distillers capable of producing 200 tons of fresh water per day. Her layout and equipment followed Resource's proven template, but even Wayland was not enough. By 1943, the Admiralty ordered the conversion of 4 more vessels into heavy-duty repair ships. HMS Artificers completed from the Cunard liner Aurania in July 1944. HMS Ausonia completed May 1944. HMS Alaunia completed September 1945. HMS Rampura completed January 1946. These heavy-duty ships were designed with workshop space capable of sustaining a workforce of 700. The Admiralty also commissioned 2 hull repair ships, HMS Mullion Cove and HMS Dullisk Cove, specifically to handle major structural damage that even Resource and Wayland could not manage. By war's end, the Royal Navy had built an entire afloat repair organisation, with 11 converted merchant ships supplementing resource, plus the 21 vessels of the Beachy Head class, built in Canadian yards on modified merchant hulls for depot and maintenance duties. The comparison with other navies reveals just how far ahead British thinking was. The German Kriegsmarine had no organised service force before the war, none. As the United States Naval Institute documented in 1954, Germany had no need for mobile support techniques because the Kriegsmarine's mission was coastal defence. German warships operated close to their home dockyards at Kiel, Wilhelmshaven, and Gotenhafen. They had a few depot ships capable of minor repairs and billeting personnel, but nothing remotely comparable to Resource. When German surface vessels operated in Norwegian fjords, a small number of repair ships and submarine tenders were stationed at larger ports, but these provided only limited capability. The consequence was strategic. Every damaged German warship had to return to a fixed dockyard for repair. When the battleship Bismarck suffered rudder damage from a single swordfish torpedo in May 1941, there was no repair ship in the Atlantic that could have helped her. When Kriegsmarine destroyers took damage during the battles of Narvik in April 1940, losing 10 destroyers in the process, there was no forward repair capability to patch damaged vessels and get them back into action. Germany lost half its destroyer strength at Narvik, partly because damaged ships could not be repaired in theatre. When Allied bombing intensified against German dockyards from 1943 onwards, the Kriegsmarine's ability to maintain its fleet collapsed entirely. Fixed infrastructure is vulnerable infrastructure. The United States Navy understood the repair ship concept earlier than most. The converted collier USS Vestal entered service in 1913, followed by the purpose-built USS Medusa in 1923. The Americans built the Vulcan class from 1941, purpose-designed repair ships that displaced over 9,000 tons and carried extensive machine shops, foundries, and hull repair capability. USS Vulcan herself supported fleet operations from Iceland to the Mediterranean to the Pacific. By the war's end, the Americans had built over 60 repair ships of various types across multiple classes. Nearly 20% of total US Navy personnel in the war were assigned to advanced base support operations, over 500,000 individuals. The American approach was industrial scale, befitting a navy that operated across the vast Pacific. The British approach was different. Britain could not match American production numbers. Instead, the Royal Navy developed a compact, highly skilled repair capability that maximized output from limited resources. Where America built dozens of specialized repair ships, Britain converted what was available and made it work through the quality of its artificers and the ingenuity of its engineers. The men who served aboard Resource and her sister repair ships were arguably the most skilled personnel in the Royal Navy. They were not recruited from the general population. The Admiralty established special repair ratings drawn specifically from the dockyards and shipyards of the United Kingdom. These men had years of industrial experience before they ever set foot on a warship. A coppersmith aboard Resource had likely served his apprenticeship at Chatham or Devonport, fabricating piping for battleships before the war. A foundryman had cast propeller fittings and valve bodies in a royal dockyard, before learning to do the same thing on a ship rolling at anchor in Alexandria harbour. Welders who could join 4-inch armour plate in peacetime dockyards now did the same work under blackout conditions, with enemy air raids overhead. Electricians traced and repaired damaged wiring in compartments that had been flooded, burnt, or blown open by near misses. Opticians recalibrated rangefinders and gun sights that had been thrown out of alignment by blast damage, restoring a warship's ability to aim accurately. These skills could not be trained quickly. They represented decades of accumulated industrial knowledge, compressed into the hull of a single vessel. Her crew called her Remorse. They served aboard her anyway, because the fleet could not function without them. The strategic impact of mobile repair capability is difficult to overstate. Every warship repaired at a forward base, instead of being sent home, represented a multiplication of effective fleet strength. A fleet of 50 destroyers with a constant 10% damaged and sent home for repair operates with 45 available at any time. The same fleet, with forward repair capability, returning ships to service in days instead of months, operates with 48 or 49 available. That increase of 15 to 20% in effective strength did not require building a single new ship. It required only the ability to fix the ones already in service. Resource and the repair ship organization that grew from her example provided exactly this capability throughout the war. HMS Resource served in the Mediterranean until 1944, when she transferred to Trincomalee for service with the Eastern Fleet. In January 1945, she departed for the Pacific as part of the British Pacific Fleet's fleet train, arriving at the American forward base at Leyte alongside the depot ship HMS Tyne and the repair ship HMS Artificers. There, she provided repair facilities for the British Pacific Fleet after operations against Sakishima Gunto airfields. She then moved to the British base at Manus in the Admiralty Islands, where she supported the fleet through the final months of the war against Japan. After the war, Resource returned to Britain. She served as senior officer's ship in the reserve fleet at Portsmouth until 1951. She was placed on the disposal list in 1953 and sold the following year. She arrived in tow at the breaker's yard in Inverkeithing, near Rosyth, in February 1954, 25 years after commissioning. Her name lived on. In 1966, a fleet replenishment ship of the Royal Fleet Auxiliary was named Resource. That ship earned the battle honour Falkland Islands 1982, continuing the tradition of logistic excellence that the original Resource had established. The repair ship concept that HMS Resource pioneered, the idea that a navy's fighting strength depends not just on how many ships it builds, but on how quickly it can fix the ones it has, remains one of the most underappreciated innovations in naval history. Every video on this channel covers the ships that fired the guns and launched the torpedoes. This one is about the ship that kept them fighting. Resource was ordered in 1927 because the Admiralty understood something fundamental about naval power. Battles damage ships. Wars are won by the navy that gets damaged ships back into action fastest. Britain's competitors relied on fixed dockyards. Britain put the dockyard on a ship. 12,300 tons, 530 feet, a foundry, a smithery, machine shops, welding bays, and the most skilled artificers in any navy afloat. HMS Resource was never famous. She never fired a shot in anger that changed a battle's outcome, but without her, and without the repair ship fleet that followed her example, the Royal Navy's fighting strength in the Mediterranean, the Indian Ocean, and the Pacific would have been a fraction of what it was. The ships that won the battles needed someone to patch the holes afterwards. Resource was that someone. The Admiralty understood it in 1927, when they placed the order with Vickers-Armstrongs for a vessel that no other navy thought it needed. The rest of the world learned the lesson the hard way. Some of them are still catching up,